Our XPS instrument locates at the Engineer Science Building, room B62. The entire system consists of a main XPS unit, an electronic rack, and a computer that operates the machine. Before you start your session, you're going to check this highlighted part of the front panel to make sure, first, the instrument on green lights is illuminated, and second, the pressure reading of the main chamber ion gauge is below 5 by -7 Pascal without sample. The main chamber pressure will be higher with the sample, but should still be better than 2 by -6 Pascal. And the main chamber pressure with the sample and the argon ion gun should be better than 5 by -6 Pascal. The abnormal high pressure of the chamber usually indicates a system leakage or a dirty sample that should not be transferred into the system. So if you noticed the system is off or the main chamber pressure is out of the correct range during the operation, please contact MCF manager for help. Here is a sketch to show the 5 basic components of our XPS system: the X-ray source, the sample on a stage, the hemisphere photoelectron analyzer, the electron neutralizer, and the argon ion gun. The X-ray source we are using is a focused aluminum K-alpha source with the beam size at 100 micrometer in diameter and 25 watts in power. The vacuum-compatible powder, film, or bulk sample could be measured in our system. The XPS is a very surface-sensitive technique, and the sampling depth is only in the order of 10 nanometers. The emitted photoelectron will be collected and analyzed by this hemisphere analyzer. We will get the distribution of the core electron from your sample as a function of the binding energy. This will allow us to identify the elements in the sample and also study the chemical states of specific elements. During the photoemission process, the sample will keep losing electrons. For those insulating samples, they could not get electron back from the rest of the system, so the sample will be positively charged during the measurement. This will create a field around the sample and distorted the XPS result. So an electron neutralizer will be needed here to add the electron back to keep your sample charge neutral and optimize the XPS result. Finally, our system is also equipped with an argon ion gun, which could generate high-energy argon ion to bombard your sample surface. This will allow you to remove the material from the top of your surface so you could measure deeper region of your sample. And specifically for this instrument, the argon ion gun could also generate low-energy argon ion and be used as a secondary neutralizer to compensate the charging effect due to the X-ray and the electron neutralizer beam size mismatch. All those 5 key components are built inside the ultra-high vacuum chamber, as shown here. This is the image of our XPS system from the side. You could see a hemisphere analyzer on our left-hand side and a cylinder-shaped main chamber on our right-hand side. The main chamber is connected to the analyzer and contains all the key components inside. If we look through this small wheel port, we will see first, the X-ray will come from the top. We have the sample stage at the bottom. We have the lens front of the photoelectron analyzer. We have the electron neutralizer. And from the back, we have the argon ion gun. Now let's take a look at the vacuum setup of this system. As an ultra-high vacuum-based instrument, you cannot simply vent the whole system to air to load your sample, since it will usually take days to weeks to pump such a large system to the desired vacuum level from air, and usually a chamber bakeout is also needed. So this type of instrument is always designed to have a sample transferring system which consists of 2 or even more chambers. Here I show the system images from the top and the side to give you a better idea about the vacuum setup. As mentioned earlier, all key components are inside the main chamber as highlighted here in the red box. The pressure of the main chamber is shown at the electronic rack front panel, labeled as the main chamber ion gauge. Next to the main chamber, there is a very small chamber, which is called the sample introduction chamber, as highlighted in the green box here. When you load your sample, you will only need to vent this small chamber to air for sample loading, and it usually takes less than 30 minutes to pump this small chamber down to desired value. A convection gauge is attached to this chamber and can also be read from the electronic rack front panel. This gauge will allow you to monitor the chamber pressure from atmosphere down to 10 to the negative 2 Pascal. And a extra cold cathode gauge is installed to the sample introduction chamber, which will allow you to read the pressure below 10 to the negative 2 Pascal. You will only need to turn this gauge on before transferring the sample to make sure the pressure inside the intro chamber is good enough. The intro chamber is separated from the main chamber using this automatic gate valve, which is controlled by the computer and could only be opened when the intro chamber reaches the desired vacuum level. Our system is also equipped with a side chamber attached to the main chamber, as highlighted here in blue box. This chamber could be used as a sample preparation chamber or sample treatment chamber, like sample annealing. This chamber is separated from the main chamber by this manually controlled gate valve. Currently, this valve is left open, which will help us to get better vacuum in the main chamber. By far, we go through all the hardware of the system. Now let's take a look at the software part. So there are 2 softwares we are going to use. The PhiSummit XPS software, which allows us to control all the key components and set up the measurement. And the Vacuum Watcher software, which control all the vacuum valves that will allow us to transfer sample between chambers and prepare certain electronics with vacuum requirement, such as the argon ion gun. For PhiSummit, we have multiple windows here. Different window has different functionality. The main menu window is for users to call all the other windows showed here, and also have a status indicator at the bottom to show the status of the X-ray source, the neutralizer, the ion gun, and the sample motion. The electronic control panel has 5 tabs and will allow us to control the sample motion, the X-ray setting, the neutralizer setting, the ion gun setting. And also we have an extra tab to set up the sample alignment. Here we have a joystick panel which will allow us to move the sample around to explore the sample surface during measurement. The acquisition panel will allow us to set up the analyzer for measurement parameters. And finally, we have the spectral viewer window, which will show the result XPS curve. The vacuum watcher software only contains one panel, but the layout could be grouped into 3 different regions. The first region contains a sketch of the vacuum setup and labeled all the valves and their open or closed status. In the sketch, the green means open, the red means closed. This panel is only for the information. The second region contains a set of pre-programmed vacuum task buttons, which allows users to perform certain vacuum-related tasks by simply pushing those buttons. For example, the backfill intro button will allow users to vent the intro chamber for sample loading. The pump intro button will allow users to seal the intro chamber after sample loading. The transfer sample button will open the gate valve between the main chamber and the intro chamber to load the sample into the main chamber. And the differential valve open button will redirect the pump from the intro chamber to the argon ion gun, which is required for argon ion gun operation. Finally, we have the system pressure reading region, which simply shows the pressure of the main chamber and the intro chamber.